Let's jump into the coding and start writing the kernel modules. So in C programming, we have main function. So this main function is the entry point and exit point. So main acts as entry point. After main, whatever the functions, whatever the code which is present starts executing. Whereas in case of kernel modules, you also have an entry point and exit point, but we have a different entry and different exit point. So kernel modules, it must have at least two functions. One is a start function, which we also call as initialization function. This function is called when the module is loaded into the kernel. Then we have an end function. We also call this as cleanup function. This function is called when the module is removed. So how can I specify my function as end or cleanup or start or initialization function? So kernel provides you macros like module underscore init and module underscore exit macros. So module underscore init macro will allow you to specify a function as initialization function. Module underscore exit macro allows you to specify a function as cleanup function. So first you need to write two functions, which is initialization function and cleanup function. And then you need to specify them using module underscore init and module underscore exit macros. Then the next step is you need to specify the license which you are using for your kernel module. There are various licenses like GPL, GPL-v2, dual BSD, etc. And you can also have proprietary license when you are when you are selling this particular code for non-free products, when you are doing commercialization on using your kernel module. So the license can be specified by using module underscore license macro. First, so we have seen two steps. Step number one, create your initialization function and exit function. Specify it using module underscore init and module underscore exit, and then specify the license for your module. Finally, you also need to include some header files. So for your C code, you used to include stdio.h, which used to have the declarations for the printf and all. Similarly, for Linux kernel modules, there are two header files which you need to include. First one is linux/module.h. So this particular header file, it has the macro definition for module underscore init and module underscore exit. We know that module underscore init and module underscore exit are macros which should have definition. Those definitions are present in linux/module.h. And we have a function known as printk, so which is like similar to printf for C functions. So we have printk, and printk uses log level. So the log level definitions are present in linux kernel.h. So you need to include two kernel headers. One is linux/module.h and the other one is linux/kernel.h. So let's look into the code. I have already a code written here. So I have included two header files, linux kernel.h, linux module.h, and then I have module underscore license. I'm specifying the license as GPL, and then I have wrote two functions. One is initialization function where I am printing a message known as init, and then I have an exit function or cleanup function where I am printing a message known as inexit. And I am specifying this as an initialization function using module underscore init. I'm specifying the name of that function here, and module underscore exit is the cleanup function. So very simple, there are three steps. Step number one, include the header files. Step number two, specify the license. Step number three, write your initialization and exit function and specify them using module underscore init and module underscore exit. So this is the basic hello world kernel module, which is doing nothing but printing a message in both the functions. And one point which you need to know is the return value of init function is int, the return value of exit function is void. Okay, so how can I compile this? We have written the code. Now I want to compile this code. In case of C programming, user space programming, we use GCC. So we say GCC hello.c and we specify another name instead of a.out. This will not work here because we do not have main and we are using kernel header files. We are not using user space header files like stdio.h. So how can I compile this? Kernel source code. So you need to use, to compile the kernel module, I need to use the kernel make file. The make file which is present in the lib modules folder. The make file by which the kernel is built. So this is the build folder for the kernel. You have a make file. It's actually a symbolic link to here. So I need to use this make file to build this module. So how can I, if I say make, I wrote a make. If I say make, it will look for a make file in this current folder. But I need to use that particular make file, the make file which is present in this folder. In this case, I use the command make-c. The C option of make command will tell the make to look for the make file in this folder. So I say make-c lib modules uname-r build. So I'm saying to the make, use the make file which is present in this folder. And I say make, if I say this, it will not work. So this particular make file, it accepts another make file. It will look for another make file. So we need to write a small make file in the current folder. And we need to specify which module to build. You may have lot of C files which are present in your current folder. So you need to tell this make file which module, the make file which is present here, which module to build by writing another make file and specifying the object file. So if you have hello.c, you need to tell hello.o. And obj-m is telling that you need to build this as module. Instead of, you have two options actually. You have obj-y, which when you say obj-y, it will be part of the kernel. But we are not compiling the kernel. We are adding the kernel module. So you need to specify obj-m. M stands for module, colon equals to hello.o. So this make file, whatever the make file which is present in the lib modules, which is kernel make file, will look for this make file present in the current working directory. So how can I specify that? I can specify that using m option. So when I say m equals to present working directory, this make file will look for the present working directory and it will build hello.o. So we need to specify. So there are multiple options to make. We need to tell this make to build modules. So the first is we say make modules. So this is the command to build modules. Very easy, right? So we need to first tell make to use the kernel make file, and then we need to inform the kernel make file to build hello.ko by writing a simple make file and specifying obj-m hello.o. That's it. And then we say build modules. So it goes into the thing and it will start building the modules. So you see warnings, it's fine for now. And you can observe the ko file is generated. So you have the hello.ko file generated. If you say file hello.ko, it's a ELF file. And we can also see mod info hello.ko. So it gives the file name, the license which we have used, And you can see we do not have an option known as entry because it's an out of tree kernel module. The module source code is not present in the kernel source code folder. It is present out of the kernel source code folder. That's the reason we call it as out of tree module. And we also have the word magic, the version magic. Now, how can I load this module? I have compiled this module. How can I load this module into the kernel? So we have a command for loading the module, which is insmod. So if you want to load your compiled module, the KO, into the Linux kernel, the command is insmod. So insmod is a program to insert a module into the kernel. So let's try to load this module. Insmod hello.ko. So as we are running as a normal user, we are not running as a root user. We are running as a normal user. Normal user do not have permissions to load a module into the kernel. Only the root user has permissions. So we need to run this command as sudo nsmod hello.ko, and the module is successfully loaded. If you want to find out whether the module is loaded or not, you can use lsmod. We have seen that lsmod, the last loaded module will be the first, and you can observe here the hello module is the one which is loaded last and it is present first. So hello module is now present in lsmod, and then you also can observe there should be a folder for hello in sys module, and yes, there is a folder for hello in sys module. For every kernel module loaded, a folder in sys module is created with the module name. Now we have in the code, we have a print k, but I have not seen this print k on the screen. But when you have used printf, you normally see that printf being displayed on the console. So this print k, will not be seeing them on the console. We need to use a separate command known as dmessage to look for these kernel messages. So you do not see anything here. This is because you have a comma here. There's a mistake in the code. Should not have comma here. So let's build this module. So let's remove the existing module. So how can I remove my existing module? The command to remove my existing module is rmmod. So insmod, ins stands for insert, mod stands for module, insert module. Similarly, rm stands for remove, mod stands for module, rmmod is remove module. So same case for rmmod, you need sudo permissions, the name of the module, and the module is removed. We can observe this from lsmod. You will not be seeing hello there. So let's build this module again using the make command, and those warnings which were present are gone. And let's load this module using insmod command. Verify whether print k is present. Yeah, function name and whatever we have mentioned in the print k is present here. And when we remove the module, this function will be called. So when you call insmod on the kernel module, the initialization function will be called, and when you call rmmod on the kernel module, the exit function will be called. Now you can observe the exit function is called. So we have seen three commands. One is insmod, which is insert module. The insmod is for inserting a module into the running kernel. Rmmod, which is for removing a module from the running kernel. And then we have seen dmessage command, which is to view the print k messages. You can also observe here we are loading an out of tree module. So whenever you load an out of tree module, it will taint the kernel. What is a kernel taint? We'll see in this course. So we have covered compiling module. So to build a module, we have seen this is the command. So, and to clean the module, so if I want to remove the module, like if I want to remove a.out, similarly, how can I do it? I can simply say, instead of make modules, I can say make clean. In this case, all the files which were generated from hello.c, like hello.mod, hello.mod.o, hello.o, modules. All these files are removed, and even the hello.q is also removed. So all the files which were generated are removed when you say make clean. So we have seen that kernel makefile will read our makefile to find out what to build, and we specify that by writing obj-m. So this we have compiled for our architecture. So we have native compilation. Suppose if I want to compile for different architecture, for example, on my x86 machine, I want to compile for ARM. How can I do that? That can be possible. For that, you need to specify two variables while you are compiling. One is arc, one is cross underscore compile. So these are the two variables which you need to specify. So arc variable specifies the architecture which you are targeting. Cross underscore compile specifies the toolchain. So you need to set the prefix of the toolchain. For example, if you have your toolchain like this, you need to chop off the GCC and you need to specify like this. So if you are cross-compiling kernel module, you need to override the default values which are present in the kernel makefile by specifying arc variable and cross underscore compile variable. So now the command changes to, when you are cross-compiling for ARM, you say make arc equals to ARM, and then you say cross underscore compile this thing, and the same thing. The remaining is -c will specify the kernel source code. We will not be using lib modules because lib modules build is for x86. We need to use the source code for the ARM thing. Let us see whether I have it. I do not have it. I have deleted it. So this is the command. So you need to additionally specify two additional variables. One is arc ARM and cross underscore compile, and then you can cross compile the kernel module.